Hello everybody, and welcome to a mathematical video on my YouTube channel Tom's Tours, a channel that has my VW California tours around all of Europe and beyond, and also some mathematics. This time is a bit of mathematics, and mainly this content today is for my S4 class, and it's about simultaneous equations. Simultaneous equations can be solved in a multitude of ways, and I'm going to be looking at solving linear simultaneous equations. My handwriting is absolutely incredible. Not at all. There are different types of simultaneous equations, and they'll be looking at different points. At its simplest form, what we have is, if you imagine we have let's say if we have an axis system, so we have a y and an x, and we have, say we have two linear functions. Let's call this one f, and call this one g. The solution is the coordinate point where they intersect, as that's the solution we're looking at. And you can plot them, and that'll give you a graphical solution. Now we're going to look at the algebraic methods in this short video. Now there are two algebraic methods we're going to look at today. We're going to look at something called the elimination method, and we're going to have a look at the substitution. There are two methods. The substitution method will always work, but it's not necessarily the quickest and most efficient method. So let's consider one example. So you would normally get this, well, you can get this in a worded thing. So for example, Sophie goes to a coffee shop, she buys 3 croissants and 2 cups of hot chocolate. It costs a certain amount of money. How much does one hot chocolate cost? Now what you've got to do is you would convert that into an equation. What you'd realize, you'd have two variables, the cost of the croissant, the cost of the hot chocolate, and it's not constrained enough because there's an infinite number of solutions. What do I mean by that? I mean, it could be anywhere along, for example, this line here. So we have to have two constraints. So let's just have a look at an example. Let's just consider something this is completely just to make the numbers nice and easy. 4x plus 3y, and let's say that is equal to 11. Okay, now x can be any value you want, y can be any value you want, it just has to equal 11. There are an infinite number of solutions here, but we need to have another set of solutions, and let's have this other set of solutions to be 2x plus y is equal to 5. Now, because we have two variables, we have the variables x and y, and we have two equations, we should be able to solve this because they constrain themselves. So we call them equation 1 and equation 2. And we're going to start by looking at what's called the elimination method. Now this is going to be the quickest way of doing this question. Now what I'm going to do is I'm going to try and make the coefficients of the x the same, or the coefficients of the y is the same. And I think if I multiply everything by 2, it's going to make things a lot easier. I'm going to multiply equation 2 by 2. So what I'm doing is I'm explaining with the working out what I'm doing. So I'm going to create a third equation. So 2x times 2 is 4x, y times 2 is 2y, and that's equal to 5 times 2 is 10. Everything is like an equivalent equation. Everything has just been doubled. We call that equation number 3. And now when we look at equation 1 and equation 3, we can see that the coefficients of the x's are the same. So let me put equation 1, let's put the equations one on top of the other. So I've got 4x plus 3y is equal to 11, and that's equation number 1. And if I put the equation number 3 below it, and you can see if I was to subtract, if I was to do 1 take away 3, I get myself y is equal to 1, and immediately the value for y drops out. Now we need to replace this, we call replacement substitution, or substitute, into, now the easiest one to do would be equation 2. So looking at equation 2, which is 2x plus y is equal to 5. So I'm going to replace the value of y. So that's 2x plus y is equal to 5. So 2x is equal to 4. What I've done is I've subtracted 1 from both sides. So 2x equals 4, and then I can divide both sides by 2. So x is equal to 2. So x equals 2, y equals 1. And it's always a good idea to highlight your answer. Now, using the same equations, we can look at something called the substitution method. This will always work, but it's not necessarily the quickest way. Substitution method. So if I just bring down these two examples again, I'm just going to copy them down so I have them with me. Duplicate, bring them down. And what I can do is I'm going to rearrange one to make y the subject, or make x the subject. It's going to make it easier. So rearrange. And what happens is, if by subtracting 2x from both sides, I have y in terms of x. And now I'm going to say sub into, sub is short for substitute, into equation 1. Every time I see a y, I replace it with the y equals minus 2x plus 5. So 4x is plus 3 lots of minus 2x plus 5 is equal to 11. Expand the brackets. 3 times minus 2 is minus 6, but it's minus 2x. 3 times 5 is 15. That's equal to 11. And you can see we don't need that plus because it takes into account. So collect the like terms. 4x minus 6x is minus 2x plus 15 is equal to 11. Take away 15 from both sides. You get minus 2x is equal to minus 4. Divide by negative 2 on both sides. You get yourself x is equal to 2. Now, we take it and put it straight back into here. So I'd normally say sub into y equals minus 2x plus 5. And it should give us the same value, y equals 1, because it's the same pair of equations. So equals minus 2 times 2 is minus 4 plus 5 equals 1. And therefore we have exactly the same again, x equals 2, y equals 1. And that's how you solve simultaneous linear equations, or linear simultaneous equations. And that's how it's done.